Hello everyone, welcome to 369 Chemistry. And many days it has been I haven't made any videos. Okay, so it was a very much gap, but from now I am promising that I'm going to make videos every day. So today we are going to start with atomic structure. Like this is very important chapter because from class 11, from 9, 10, 11, 12, and up to degree, even up to graduation, even up to masters also, it is going on. Why? Because this actually holds the whole chemistry. Like with the chemistry which we talk about, it is the reaction of the molecules, the atoms, which are very minute in size, or you can say which we don't even see by our naked eyes. So there the reaction takes place. So basically the structure of the smallest particle, that is called your atom, has to be defined. If we don't know that, okay, and if we don't go to the micro level, then we are not going to understand the very small different reactions and why they are occurring, what is the cause of occurrence of different reaction. Okay, so many reagents they are mixing up and giving you one reagent. Why? So those things, if we have to determine, we have to go to their structures. Even when we go for understanding any, so suppose you have salt. Okay, so first we can understand the structure of the salt, we can understand the taste and everything. So these are physical properties, but if you want to go for the chemical properties, you have to go to the minute level. So you have to know the structures and so many things. So this way, when we see the structural identity of anything, so we have to first define what is an atom. So an atom is nothing but it is the smallest particle. Okay, if you break anything, the smallest particle you ever achieved is we thought it is atom, but now it is not, because atom can be further divided into your nucleus, proton, neutron, electrons, mesons, okay, neutrino, positron, so many things. So atoms is no longer now the smallest particle, but before it was thought to be the smallest particle. Then next it comes about electron, proton, neutrons. Okay, so electron repulsions or electron attractions, then electron proton reactions. So many reactions are there which we are going to study in chemistry. So first, starting with the structure, the first time John Dalton found the model of atomic model. He actually predicted the atomic model. There are many models in this chapter. We will discuss about the many models. First, it was proposed by John Dalton in year 1808 and depicting the atoms as the ultimate particle. Okay, the theory of the Dalton did not hold long. Okay, it was proved by through the experiment and research by J.J. Thomson, Rutherford, Niels Bohr. So these are the scientists who actually worked on the structure of the model of an atom, for which we know now what is an atom. So John Dalton was the first one who just gave little bit knowledge about the atoms, and then further experiment was done by J.J. Thomson. Okay, then Rutherford, Chadwick, Moseley's. Okay, and they have found out that now atoms can be of different shape, size, particles. Like if you divide it, you are going to get positron, neutron, proton, and then there is a nucleus, and everything was decided. So these were decided by particular models. So those models we are going to discuss in this chapter. Okay, so remember the Goldstein discovered cathode rays, but the explanation of the properties of the cathode rays and the discovery of the electron was done by J.J. Thomson. Okay, so first Goldstein was a scientist. He discovered the cathode rays. He did the cathode rays experiment, but the explanation he could not provide. So it was provided by J.J. Thomson. So what did J.J. Thomson say? He gave a plum pudding model. Like he discovered, he said that an atom is nothing but it is a sphere. Like you can say it's like a watermelon, like where you have the positive sphere is there, and then you have negative charge all that is embedded inside the atom. And that's why you can say those small black seeds of watermelon is like the negative charge, and the whole watermelon is a positive charge. So he proposed that model. The plum pudding model was proposed by J.J. Johnson. So now, why did he say this? So when there was a cathode rays experiment was done, he saw that there are some cathode rays, okay, which directly passed through the nucleus. Okay, it directly passed through the nucleus. There was no deflection, whereas some rays it deflected completely. Okay, and some it directly passed through it. So that's why he said that the negative charge is in the whole sphere. That is it is surrounded in the whole sphere. It is flowing just in the whole sphere, because many times when these cathode rays are positively charged, so when it is it is directly passing
which means that there is no repulsion and it did not find any repulsion. So this was J.J. Thomson model, and we'll do the other things in the next class.